Hello learners, welcome back to another exciting math journey. Let me ask you, when you line up in the school canteen, your first, second, third, fourth, that order is exactly what we call a sequence. In mathematics, a sequence is simply an ordered list of numbers that follow a definite rule. Each number in that list is called a term. We write the terms as a sub 1, a sub 2, a sub 3, and so on up to a sub n. The subscript shows the position. For example, if we track the growth of a population each year or the amount of money deposited in a bank every year, we are looking at sequences. Some sequences are finite, like a list of 10 students. Others are infinite, like counting numbers that never end. That's the world we are entering today, the world of sequences. Let's explore some fun examples. Think about your family tree. You have 2 parents, 4 grandparents, 8 great-grandparents, 16 great-great-grandparents, and so on. That is the sequence 2, 4, 8, 16. Notice how it doubles each time? Now, divide 10 by 3. The first quotient is 3, then 3.3, then 3.33, then 3.333, and so on forever. That's an infinite sequence. For even numbers, we have the formula, a sub n equals 2 times n. So when n equals 5, we get 10. For odd numbers, the formula is a sub n equals to n minus 1. And then there's the famous Fibonacci sequence. Start with 1 and 1. Each new term is the sum of the 2 before it. So we get 1, 1, 2, 3, 5, 8, 13, and it keeps going. Fascinatingly, these Fibonacci numbers appear in sunflowers, pine cones, and even the spirals of galaxies. Here's a big divide: finite versus infinite sequences. A finite sequence has a last term. Think about 10 generations of ancestors. That sequence stops after 10 steps, so it's finite. An infinite sequence has no end. The decimal quotients of 10 divided by 3, 3.3, 3.33, 3.333 go on endlessly. Mathematically, we write a finite sequence as bracket open a sub 1, a sub 2, dot dot dot, a sub n bracket close. An infinite one is bracket open a sub 1, a sub 2, a sub 3, dot 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 bracket close. So the main question is simple. Does your sequence stop or does it run forever? Now let's make it practical. Suppose I ask, what's the 100th even number? Listing them one by one would take forever. That's where the general term comes in. For even numbers, the formula is a sub n equals to n. So, if n equals 24, then a sub 24 equals to into 24, which equals 48. For odd numbers, the formula is a sub n equals to n minus 1. So, if n equals 10, then a sub 10 equals 2 times 10 minus 1, which is 19. But not all sequences have neat formulas. Prime numbers 2, 3, 5, 7, 11 don't follow a simple formula. We just describe them verbally. The general term is like a shortcut on Google Maps. It jumps directly to the term you want without making you walk through every step. Here's a powerful way to think about sequences as functions. Formally, a sequence is a function from natural numbers to real numbers. That means you put in a natural number n, and out comes the term a sub n. For example, f of n equals 2n. If n equals 1, then f of 1 equals 2. If n equals 2, f of 2 equals 4. If n equals 3, f of 3 equals 6. That gives us our even numbers again. If you plot this on a graph, you don't get a continuous curve, but dots, 1, 2, 2, 4, 3, 6, and so on. It looks like stepping stones marching upwards. So, think of every sequence as a function with domain equal to the natural numbers. Now let's meet the different types of sequences. First, the arithmetic progression or AP. Here, we add the same number each time. For example, 2, 5, 8, 11, where each step increases by 3. Second, the geometric progression or GP. Here, we multiply each time. For example, 2, 4, 8, 16, where each step is multiplied by 2. Third, we have recursive sequences, where each new term is built from earlier ones. The Fibonacci sequence is the star here. Start with 1 and 1, then keep adding the previous two terms. Finally, there are irregular sequences such as prime numbers 2, 3, 5, 7, 11. They don't fit a simple formula, but they are still sequences. Identifying the type, arithmetic, geometric, recursive, or irregular, is the first key to handling a sequence correctly. Let's practice with an example. We are given the formula. A sub n equals bracket open and minus 1 bracket close into bracket open 2 minus n bracket close into bracket open 3 plus n bracket close. We want to find a sub 20. Step 1. Substitute n equals 20. So, a sub 20 equals bracket open 20 minus 1 bracket close times bracket open 2 minus 20 bracket close times bracket open 3 plus 20 bracket close. Step 2. Simplify. That is 19 times negative 18 times 23. Step 3. Multiply. 19 times 18 equals 342. Multiply by 23 gives 7,866. Apply the negative sign. Result is minus 7,866. So, the 20th term of the sequence is negative 7,866. Notice the negative result. It comes from that negative factor in the formula. Let's wrap it up. A sequence is an ordered list of numbers defined by rule. It may be finite or infinite. Each term is written as a sub 1, a sub 2, and so on, with the general term a sub n giving us any position directly. We learned to see sequences as functions. We classified them into arithmetic, geometric, recursive, and regular ones like primes. And we solved a worked example step by step. That's sequences, the building blocks for series, limits, and much deeper areas of mathematics. And in our next session, we'll move from simply listing numbers to actually adding them up. That's when we step into the world of series. Stay tuned and keep sequencing your way through math.